Hey students, good to see you again. What we're going to do today is we're going to continue on our lessons in vectors, and we're going to learn a concept today called vector addition when we add vectors together. So this is a problem we worked on last time, and that problem involved a vector that was going at 65 newtons to the northeast, and we had another vector here, kind of the pinkish purple, that was going 60 degrees, and it was at 35 newtons. So the magnitude on this was 35, and the direction was 60 degrees west of north. And then the other one right here, this blue one, was 65 newtons. It's a force. We'll learn about forces in a moment. Just know that a newton is a measurement of force, and that was 30 degrees. Now, what we learned last time was that we could solve for break these in what are called resolution or resolve these vectors. So we could find out what the horizontal or the eastward component of this was using some trigonometry. And we figured out what the north or the other axis here. So we had the two resultant vectors for this blue one here was that he had a force that was going 56 newtons towards the east and 32.5 newtons towards the north. And likewise, we had other, on this one over here, on this vector, we had 17.5 newtons to the west and 30.3 newtons to the north. So what we're going to do today, I want you to imagine that this is a ball. This is a ball that has been fired up here. So this is a vector going on this direction. And then you have a ball that's fired that's going on this direction. I want you to imagine for a second that these two balls are going to collide together. They're going to come and collide. Now you can imagine them to collide. The two momentum and the two forces are going to collide, and then there is going to be a result. When the two of them collide, there's going to be a result. So what we're going to figure out today is, knowing this vector is going in this direction, a ball is going in this direction, and another is going in this direction, what would be the resultant vector? Now you can imagine if this one has more force, it has 65 newtons, this one has 35 newtons, that the resultant vector might be a little bit in this direction. Let me get the pointer out right here. The resultant, since the blue vector has a little bit more force, almost twice the force, that the resultant is going to be somewhat in this direction here. It's not going to become completely stay the same path. It's going to be knocked off a little bit by this pink one. So the resultant vector is going to be something like that. You can imagine that that's what happened. Now we're going to show exactly what that resulting force would be when the two forces meet. When they meet, in what direction, the exact degree direction they will go. So that's what's called vector addition. So we've resolved those two vectors, and so what we've done here, and I'll be flipping back and forth between screens. So we've resolved in the first, our blue one, so I have our one in blue here. That was our first vector in blue, and in blue here. So here's our blue one. So we had a direction going, the blue one was going to the east and to the north, and then our pink one here to the north and to the west. Okay, so here we have our east vector and our west vector. Okay, then we have our north vector, and then this was also our north vector. So what we're going to do is we're going to add up the vectors in each direction. So the ones going east-west, we will add together. So this 56.3 and this 17.5, we'll add those together to find out what the east, when these two collide, what is the total force in the east-west direction. And then we'll also know what the force is for the north vector, since they're both going in a northerly direction, so they both have northern components to them. So what is the resulting northern direction when we add those two together? So those are the vectors we resolved, and now we're going to add them together. So here we add up our east vectors. So we had 56 newtons in the east minus 17.5. So one direction is east, that's positive, and the west is going the opposite direction. So we subtract that. So the resulting vector in the east is 38.8 newtons to the east. So I want you to think about this. This is coming in at 56. This is coming at 17. And there's going to be a resultant a little bit in that direction towards the east. So it's not as strong as it was because it's fighting against this force here. Okay, now the other two, we have the north-south. Now, since they're both going north, and remember, both of our vectors are going north. So here we have an overall east vector and west vector, and they collide. But both of these are going north, so they're going to add to one another. Since they're both going up, there's an upward trajectory on both of these. These vectors will add and not subtract. So the resultant vector, here's our first one, is 32.5 going north and 30.3 going north. And so what we have is 62.7. So what we have here is we have an overall vector of the objects when the two balls hit together. The resultant vector is going to be to the east and up towards the north. To the east, a force of 38.8, and towards the north, 62.8. Okay, so what we'll do is we'll draw that again. Okay, so we take our we added up our east-west vectors, and we added up our north vectors, and here we have another triangle. So what we want to do is what's going to be resultant when these two collide? What direction will they go in? At what force? So here we have just a right triangle again. We have a small side A, a medium side B, and a hypotenuse C. So we just use the Pythagorean theorem is a squared plus b squared equals c squared. So we have a right triangle here because because we have a right triangle, we can use that. So our A, our small side, our overall east is 38.8, and because it's a squared, we square that. And then we have 62.8 as our B. And then we square those two, sum them, and then take the square root, and we get a resultant vector of 74. So when these two add together, the resultant force is going to be 74. The force combines from 65 to 35. They combine, they add together to form 74. So the resultant force, upward force, in this direction is going to be 74. Now we need to know exactly what angle is that going at. Okay, so that's what we're going to use our trigonometry from last time. So we'll pick one of these. We could pick any one since we know all three sides. So what we're going to pick, the hypotenuse and the adjacent and the opposite side. The opposite side. All right. So what we do is if we pick the opposite sides, remember this angle right here. We're trying to figure out what this angle is. And the opposite side, remember shooting an arrow out of here, our opposite side would be this. So the sine is the opposite over the hypotenuse. So sine of that angle will be opposite over the hypotenuse. And if we do that, that would be 62.8 divided by 74. And we multiply that times the inverse, or we're thinking about it as dividing by the sine, and that is 58 degrees. So the resultant vector is the sum of those vectors is that when these two come together, those two balls smash into one another, the resultant force is still an upward force of 74 newtons, and the direction is going to be 58 degrees northeast. So very much what we thought. So let's go back to our graph here. So if this is right here, this is going to continue at a 58-degree angle right here, about 58 degrees. That's roughly 60. So I was kind of estimating. When these two collide, the resultant force is going to be 74 force at a 60-degree angle northeast. Okay, so let's try another one here. We have another example we'll try. Here. We have a motorboat. So imagine we're going down a river. We're going due east in a river in a motorboat. Okay, so let's say you're going due east in a motorboat, but you also have the river is flowing. So the river is flowing in a northerly direction. Okay, and so here's one side, and you're trying to cross to the other side. So you're going to go due east in your motorboat, but you have a current that's pushing against your motorboat going this direction at 9 meters per second. So you're attempting to drive across here, but there's going to be a current that pushes you in a resultant direction. So that's what this results right here. So what happens if you just go across at a constant speed and you don't try to steer into it, you just go straight, don't change your steering at all, you will be pushed downriver down to here. So even though you started here, because of the resultant current that is pushing at you at 9 meters per second, you'll end up down here. So what is this what is this resultant force right here? And at what angle would that be? Okay, so we're going to do some, we're going to resolve these vectors here. So what we'll do, well, let me move my picture out of the way here, move myself down here. All right, so since the two motions are perpendicular to one another, perpendicular means perpendicular is 90 degrees, okay? Since one's going due east and due north, when those two intersect, there's a nice 90-degree angle there. So that's what perpendicular means. They can be assigned to the legs of a right triangle. So we have a squared plus b squared equals c squared. So a is our 9 meters per second, our current, and 16 meters per second are the speed of our boat going east. So here's our b, which is the medium side. The short side is a, it's 9, and then the resultant is a hypotenuse, what we're trying to find. All right, so the same thing is if we do a squared plus b squared equals c squared, we take the square root of our answer, we will get our resultant vector will be 18 meters per second. 18 meters per second. So that means that this right here, the speed of which we do this, even though we're going 16 meters per second here and 9 meters per second that direction, the resultant speed or velocity will be 18 meters per second in this direction here. Okay, so now we'll know what angle that's going to be. What is the angle that we're going to be pushed off course, so to speak? So we'll take the sine, okay, because the sine, so here's our angle, the opposite is our 9, and we already know what this is over our hypotenuse, which is 18. So we take our opposite over our hypotenuse, 9 over 18, which is 0.5, divide times the inverse of sine, or think of it as dividing by sine, and that's going to be a 30 degrees. So to answer our question here, oops, let me go back up here like that. To answer our question here is that if we have a motorboat going across a river at 16 meters per second and have a current that is going due east at 9 meters per second, we will be blown off course 30 degrees at a speed of 18 meters per second. All right, so that is, there's a few practice problems that I have signed you, and I want you to practice those vectors. There's also a PLIX, P-L-I-X, that you can try as well. So read section 1.6, go over some of those example problems, and also practice a few to get familiar with some of your trigonometry using some of your sines and cosines, and also how to set up your Pythagorean theorem. Okay, that's it for today, and I'll see you next time.